welcome you to the 48th lecture of NPTEL online certification course Drilling and Blasting Technology. Title of this lecture is Concept of Blastability. We will discuss what is blastability at a later stage. Let us retrospect first what so far we have covered. We have covered understanding of the rock mass, then we have covered the drilling technology, how the drilling is carried out, what are the different methods of drilling. Then we have carried out the understanding explosive, then we have carried out how the explosive is energy is utilized for rock fragmentation. So, that is explosive rock interaction, and then the blasting technology for bench blasting, for underground blasting, and after that we have seen the results of blasting in rock mass. Then we have already carried out some tutorials related to drilling and blasting designs, their cost analysis, and in last few lectures we are discussing the impact of rock and rock mass on the blasting technology, how the blast designs are being influenced by the rock and rock mass properties, especially the orientation of the joints, discontinuities which are there in the rock mass, how that is affecting the blasting design, the blasting results that we have discussed in last few lectures. Now, we are at a position that we understand the influence of the rock and rock mass on the drilling and blasting. In drilling it is drillability, it is already discussed. In blasting we termed it as the blastability. So, this blastability is basically the parameter, or you can say a concept that is defining how the blasting is being affected by the rock mass conditions. So, the objective of this lecture is to understand the methods to designate rock and rock mass from blasting objective points. Now, rock mass classification system is basically the system which is designed for blasting point of view, and the blastability is basically defining the easiness to blast that particular rock mass, the impact of that to the target results, and the consumption of the explosive energy for economic point of view, and basically it is an indirect way to arrive at the powder factor. So, basically blastability is the concept which defining the rock mass, that is how easy to blast, and that easiness is being influenced by the desired result, by the rock mass properties, by the economic point of view. So, that is how that can be carried out is basically the objective of this one. So, suppose in this case let us consider this is a rock mass, a particular cube of the rock, this is the particular rock, this particular rock cube has to be blasted using this hole. Now, there are maybe some discontinuities, may not be some discontinuities, but we have to place some explosive inside this hole to fragment the rock. Now, we are having different options, we can have a fragmentation distribution size of this type, we are having fragmentation distribution size of this type. So, we have to first find out which one is our target, whether this is our target to achieve a larger boulder size, or this is our target to achieve the finer products. We have to find out whether our target is to throw the rock at a away distance or not. So, these are the results, and based on that we have to designing this blast, we have to consider these discontinuities, their orientations, and based on that the charges has to be placed in that rock. And considering all these things, what is the quantity of charge that has to be placed there is called the proper design, and to arrive at that the concept is called blastability. So, blastability can be defined as the blasting characteristics of the rock mass subjected to a specific blast design, explosive characteristics, and specific legislative constant depending on the site specifics. So, this is basically depending on the explosive properties, rock mass properties, the blast design properties, the result properties, and what are the legislative constant at that position. Say for example, in India currently we do not have the provision to use nitrate based explosives like dynamite etc. We are only depending on the ammonium nitrate based explosives. So, that is the problem, and foam emulsion slurries are that. So, our definition of blastability, we cannot consider that this blastability has to be defined where we are carrying out blasting using the dynamite or using the gelatines. So, that is not possible for this current condition. So, basically the blastability has to be designed, has to be evaluated based on the available explosive characteristics, the in situ rock mass conditions, the possible blast design in that particular area, particular concepts say like drill dia may be a constant, may not be a constant. So, all these considerations has to be made during that analysis. Okay. So, in other words, blastability basically defines as how the rock is easy to blast under a specific condition is called blastability. Now, let us see how different way the blastability is defined by different researchers. To understand the difference of the target of the blast, let us see these two videos. You can see this is the video where the simple blasting is carried out. This is a high speed video, is showing in a low space, so that you can understand. So, the objective of this blast is a single row blast. The objective of blast is only to fragment the rock mass having the proper throw, having the proper heap formation for the final recovery of the material, post blast material. Okay. So, this is the objective of this blast. However, the objective of this blast is completely different. This is a cast blasting. This blasting is basically carried out to throw this rock mass, from this bench to the overburden bench which is observed in the front direction. So, the maximum throw as much as possible is basically made here. So, objective of this blast and this blast was different. Here basically you can see the huge rock mass is thrown in front direction, so that the maximum displacement of the fragmented rock material can be achieved. So, the objective of both the blast are entirely different. Obviously, that basically dictates the blastability of the rock mass are different, because they may be the same rock mass, but the target results are different. So, that is why the blastability is different on that point of view. So, this is the understanding of the results, impact of results on the blastability. Now, the first blastability concept was given by Hino, and he proposed that blastability as the terms of blasting coefficient, which is nothing but the ratio of compressive strength to the tensile strength. Basically, he found that this ratio is very much important for the transfer of energy from explosive to rock, and considering that, he has come out with the concept of blasting coefficient as the compressive strength by the tensile strength. In 1968, Hansen has come out with a formula which basically dictates the total charge required in a single hole with free burden. That means, the burden condition was free, it is not choked, and he considered that quantity required in a charge to achieve the desired blast result for that particular was depending on the burden, height, rock constant, which are basically estimated from the trial blast, and he has used different fixation factor for vertical hole, for inclined hole, for explosive factors, for dynamite of different percent gelatins, all those are basically considered by him, and he has come out with this concept with this formula, and this is basically one type of blastability model which guides you the charging of the hole to achieve your desired result. So, that is basically the requirement in blasting, but here the rock properties, only the rock constants which are basically proposed by different researchers, that time rock factors was considered by him, no other rock properties or rock discontinuities are considered here. Easiness to blast was defined by Langefors in 1978 in his book, where he has used the rock factor to define the charge required to achieve the desired result for blasting a particular rock. So, he has carried out the trial blast in granite, a number of trial blast in granite to come out with the decision, and he has found that a rock factor of C is equal to 0.4 may be good for the moderately strong rocks, and that rock factor can be assumed which can give you the desired blasting result. So, this concept was that this 0.4 kg per meter cube concept is that in a cubic meter of rock, if a central charge of 0.4 kg is placed, then that is giving you the best blasting result. So, in that concept this has this result has come out by the Langefors-Killstrom, and till date many of his blast design formula, in fact, in our earlier lectures we have discussed Langefors-Killstrom blast design criteria for surface mining, bench blasting, for underground blasting, wedge cut and burn cut pattern. So, all those formula they are the C, this rock factor was popularly used, and that is basically come out with this blastability concept. Bourque in 1981 also recommended a blastability factor from the Peirce equation, where RQD was considered, and a correlation has established between the powder factor and the RQD. So, this equivalent RQD was considered as the RQD into the alteration factors, and alteration factors the rock mass properties, that is the joint strength, strong, medium, weak and very weak are considered, and considering that this blastability factor was established there. So, this is basically a statistical method used where particular case study is carried out and the correlation factor was established. Similarly, Heinen and Dimock also for the copper mines in Nevada, they have also come out with that case study where they have used the seismic propagational velocity, that is the P wave velocity, acoustic velocity they have used to define the rock mass condition, and they relate that with the powder factor. Okay. So, they relate that with the powder factor equivalent to ANFO, and that is basically they have used a correlation and found this is the average of different experiments they have placed in this, figure you can see. So, this pattern they have used for pattern size for 9 holes, and they have come out with that, and this acoustic velocity is basically considered as the rock mass properties. In fact, this acoustic velocity, that is the P wave velocity of the rock is a very good tool to define the condition of the in situ rock mass, because it is basically depending on the strength properties also the number of joints, that is also influencing, and the condition of the joints are also influencing this one. So, similar system is also used by Ashby in 1977, where fracture frequency was considered as the influencing tool, and based on that the powder factors are decided, and the powder factors are basically given using this formula, where phi is the friction angle and I is the roughness angle of the joints can be determined using the shear test of that rock mass conditions. Okay. So, these are basically considered and these are the for different friction angles, these curves are made, and these are the abrasive angles, I is the abrasive angles and sigma r is the in situ formations, in situ density of the rock, that is the bank density of the rock, are considered in this correlation analysis. Okay. In 1982, Layton has come out with the relationship between RQI and rock quality index and the powder factor expressed in terms of ANFO for perimeter blasting, that is the control blasting techniques. So, and this is also another regression analysis, and in this regression analysis RQI is defined using this formula, which is considered as the considered from the drilling parameters. So, this is the drilling rate and this is the length of the hole. So, this is basically drilling rate has come out from this, and this is the hydraulic pressure of the drill is considered while the rotary drilling is carried out, the hydraulic pressure on that is considered, and based on that the rock quality index has determined. And it is found that there is a very good correlation exists between RQI and the powder factor, and that is basically expressed in this figure also. There is this powder factor from the drilling analysis, there are few such studies are there. The benefit of this study from the drilling analysis is that this assessment can be carried out each time while the drilling for the blasting holes are being carried out. So, from the drilling rate itself, one can decide what powder factor they should consider, that means, what is the charge per hole should be considered for that particular rock mass. So, suppose one blasting is carried out in this rock mass. So, while the drilling is carried out here, based on the drilling rate, so based on this drilling rate what we have achieved, considering that we can decide what is the powder factor has to be placed. So, the moment we know the powder factor, we know the quantity charge required, because this is divided by powder factor is divided by this, this is burden into spacing into bench height is the quantity. Okay. So, this is divided by the charge from that can be considered as the powder factor. So, if we know the powder factor required for from this particular drilling condition, then we can easily calculate what is the Q required, because already the burden, spacing, bench height are fixed here. So, we can easily decide what charge, how much charge should be given in this particular hole. So, this is the benefit where the charge quantity can be immediately decided from the drilling parameters, and that is why there are few blastability concept has come out based on the drilling parameters. One such parameter is also given by Gimeno also, we will discuss that at a later part. In 1982, Rakhisev has expressed blastability as a function of density. Again POF velocity he has used for considering the rock mass properties, Poisson's ratio, elastic modulus, compressive and tensile strength of the rock mass, and mean dimension of the natural structure units. So, they have considered this and also considered a coefficient representing the properties of filling of the fractures and their degree of opening. So, whether the joints are filled or not filled or it is tightly filled. So, that is also considered here, and considering that he has given this formula. So, this is basically in this case the blastability is considered the rock properties in a holistic way, but the properties of the results are not, blasting results are not considered here. So, basically this is basically the critical fracture velocity is determined using this formula, and based on that the easy to blast, moderately easy to blast, difficult to blast, very difficult to blast, exceptionally difficult to blast are considered. So, if the critical fracture velocity is less than 3.6, it is easy to blast. If it is more than 6.3, it is difficult to blast. So, that is the concept Rakhisev has come out, and these details are formula given in this place. So, as we have discussed, this another drilling index given by Gimeno in 1984, that is called IP drilling index. So, this IP drilling index where the penetration rate is directly considered, then the normal force given onto the beat is considered, drilling speed, that is the RPM of the drill machine, and diameter of the drill hole is considered, and based on that the rock is categorized as the drilling index, and the powder factor is correlated with this IP drilling index using this formula, and that is why this is also a very useful tool. This is also a very useful tool to arrive at the charge requirement for the blasting condition of that particular phase, and that decision again can be carried out while the drilling is being practiced in that bench. From the drilling results, observing the penetration rate only, that decision can be made, and that can be immediately applied for the blasting round. Similarly, Lilly has come out with the first concept of rock mass classification system, where blasting index was considered as a function of rock mass description, joint spacing, joint orientations, specific gravity influence, and the hardness of the rock material, and a rating system is considered just like the rock mass classification RMR Q index are there, and based on that this classification is made, and how to calculate all these things, these are given in this slide. So, based on that he has come out with a guideline for the powder factor based on the blasting index and the powder factor. So, this relationship is given by Ghosh, where he has little bit change in the blasting index, where the rock properties are changed to the density ratio, discontinuity spacing ratio, adjustment factor 1, point load index, adjustment factor 2, and joint plane orientation. Basically, point load strength index is a very good tool to replace the compressive strength index, because point load strength index does not require the sample preparation, it can be easily determined at the face. So, that is why at the face itself the point load index can be determined and the blasting index can be immediately calculated in that. So, that is why this is the blastability index, from where it is correlated with the powder factor. Again, the results of the blasts are not considered in this case also. In the previous slide, the parameters are shown to you, that how to rating of these parameters can be achieved, that is given in this particular table. So, this is the density ratio, the density can be achieved if the density is less than 1.6 ton per meter cube, then this is the rating. If it is more than 2.5, then this is the rating. Similarly, discontinuity spacings, if it is less than 0.2 meter, then this is the rating. If it is more than 2 meter, this is the rating. So, in between ratings are given. Point load index is also given. If it is less than 1, then it is 25, it is greater than 6, then it is 5. Similarly, joint plane orientation, this is deep into face, strike normal to face, this is strike at an angle acute to face, then deep out of the face. For all these conditions, the ratings are given. So, this can be easily based on that, it can be easily implemented for a particular face and the rating can be obtained. There are two adjustment factors. Considered in this rating. The adjustment to second factor is basically based on the burden by hole depth, that is this is the burden and this is the hole depth. So, this is basically giving us the idea about how this column is being formed. So, this concept of column building is basically considered. So, that is considered as the adjustment factor. You understand, if the long column is there, that is easy to break. So, it is easy to break condition. If it is not a very big column, it is difficult to break. So, that is basically considered here. If the hole depth by burden ratio is more than 2, it is considered 0. If it is less than that, there is some negative ratings are given. Adjustment factor 1 is basically the condition of the free face. If the free face is in confined condition, that means it is choked, the free face is choked, in that case we have to consider, if the free face is choked, in that case we consider the face is confined, and in this case highly confined case we have to consider a negative rating there. But if it is free, if there is nothing, the face is free to throw the rock in front direction, in that case we consider it is reasonably free, it is 0. So, these are the how these ratings are considered, that is basically one can easily calculate using this rating table. So, that is very easy to follow this rock mass classification system, which is developed in India with different with a number of case studies carried out in Indian bench blasting. Professor R. N. Gupta in 1990 also come out with a formula where the directly charge factor can be obtained, and the rock properties is considered is the Protodekanoff index, which is considered as the rock property, and based on that with the designed burden, the charge factor can be easily calculated using this formula. So, basically Protodekanoff index, strength index is the strength index which gives under the strength index of the rock subjected to a dynamic loading condition. All other index like compressive strength, tensile strength, these are the strength index under the static loading condition, but the Protodekanoff strength index is the case where the rock is subjected to a dynamic loading condition, where the hammering of the rocks are carried out to understand its strength. So, that is why this decision is made based on the dynamic load condition, and charge factor is basically defined based on that. The best so far, the best blastability concept is given by the JKMRC, the Australian Research Institute. They have come out with this blastability concept, where the rock mass properties, structural properties, that is the block size in rock mass conditions, the design concepts, the environmental impacts, that is the rainy conditions, watery holes, all these conditions are basically considered to arrive at the blasting results by the by this particular blasting operations. So, they have carried out with this analysis for a mine to mill concept, for in one of their project in mine to mill concept, where they have used explosives and come out with the parameters like this. They have used strength parameters, rock mass parameters are strength, density and Young modulus. This is basically rock properties. The rock mass properties, they have used block size, structures of that. They have design considerations, they have used target fragment size. This result has come out, this is the target fragment size, what is the average fragment size, post blast fragment size, what is the D50 average fragment size is required, desired, that is considered here. What is the heave required and the confinement conditions, the scale, all these are basically considered, and the environmental watery holes or non watery holes are considered. Based on that, they have come out with the strength indices here, this all this they have considered at this position, and based on that they had come out with the powder factor. So, this is the basically powder factor in kg per ton using this density. If you change that, then you will get the powder factor in kg per meter cube. So, here the particularly the results of the blast are also considered as a parameter where the blasting is carried out and the results are basically desired, for that is also to be included in the blastability conditions. So, the JKMRC is basically this is the description how one can come out with this, one can come out with the values of for this particular table, those values. This description is given here, what will be the in situ block size, then how that has to be considered, the rating has to be considered here. So, confinement is based on the free phase availability, a blast having full phase available has confinement less than 5, over confined greater than 5. So, these are the factors which one can consider. So, you can easily follow this if you read this. These are the how you will consider the different strength indices. So, those descriptions are given here, and that is why this JKMRC concept is the best concept, where the blasting results are desired blasting results are considered as the input also. So, considering this, this is so far different studies carried out on the blastability. So, blastability once it is defined, it is very easy to come out with the powder factor. So, the design can be complete with that, and based on that we can execute the blasting. So, this is more or less the impact of rock and rock mass properties on the blasting. Thank you.